The Smart Solar Disconnect Control Unit. And so we'll be testing this microcontroller here. And over here, the only thing we're using on this board is the potentiometer that we're going to be adjusting to check logic levels. So the first step is to take the output of the potentiometer and hook it up to the data in pin. That should make the green light go on, and then we're going to do some tests on the PWM, the short enable, and the PMOS enable with an oscilloscope later. So first, this is the output of the potentiometer, this is the current draw, and this is what we'll be using to test levels on the outputs. We need to make sure that the current draw anomaly is less than 5 milliamps and does not exceed 10 milliamps. So let's start with the test. We're going to hook up 4.58 volts, or 5 volts. We want to go a little under 4.5. It has to be high at 4.5. Okay, there's 4.5 exactly. Okay, we're going to hook up data out. We're going to hook up a high, or data in, a high to that. Okay, we see the green LED turn on, and we should also notice that the PMOS enable is high, which we see here, and then we're going to see about 0.5 volts for 10% duty cycle on the pulse width, and then the short enable will be low. Okay, so the next step is to lower the potentiometer to 1 volt, and we want to make sure that that turns off. Now we're checking logic low level here. So we're going to lower it to 1 volt. Oh, that's up. I'm going to go down. Okay, turned off at about 1.55. And so we'll keep it just above 1 volt. And then we'll check those outputs. We should see them flip. So PWM is off. We should see PMOS off, and we should see short enable high, which we do. Testing the temperature input, analog input, and the alarm enable output. So once we raise the potentiometer above 1.5, which corresponds to 100 degrees C, we should see the alarm output come on. So I have this already hooked up to the alarm output. We're at logic low right now, which is below the 1 volt threshold. We're going to raise up the alarm, or the temperature sensor, to about 1.5. See if I can get it down a little closer. Okay, so it's pretty close there. And we have an output of 5 volts, which is higher than the prescribed 4.5 and less than the 5.3. Now let's lower this back down. We should see it drop down to logic low again. And there you go, it fell below 1 volt. Okay, so we will be testing the current sensor input. This sensor should push the yellow LED on when it reaches a threshold of 0.35 volts. And this should turn on the data output terminal when this happens. So currently we're at 1.65. We see the LED is off. Let's raise that up. It's the yellow LED, sorry, my mistake. Okay. The LEDs aren't functionally important. They are just there for testing, really. So we can see the threshold there is right at 3.5 volts, and it's very, very close. 3.5. So we'll check the data output pin. Oh, it's blinking, so I gotta adjust it up a little bit higher than exactly 3.5 because it's static. Okay, so we are at 5. Now let's check our. So that's falls within. It's greater than 4.5 and less than 5.3. We're going to reduce this voltage down to below 1.5 or 3.5. Sorry, and we should see it turn off, which we do. And it reaches a logic low of 0.03. Okay, that concludes the testing of the disconnect controller unit sequence and frequency test. So we're going to be doing a falling edge test on the PMOS and short enable, and we'll be checking the frequency of the PWM output. So I have the oscilloscope set up to do the falling edge test. We're going to enable the disconnect, so it's in on mode. The purple is the short enable, the yellow is the PMOS. So I'm going to drop it off, and we'll see that the PMOS disengaged with a small delay before the short enable pin engaged. Next we will check the opposite relationship. So we will watch the rising edge.
We get like 8 page.
Nope. Okay, let's test the rising edge.
I don't know.
You guys already had your.
It's not triggering.
I've been feeling okay about the homeworks.
For closing the disconnect, so we should see the short enable, which is purple, go off, followed by the PMOS, which is yellow, enable.
I mean, that's kind of what that contract at the beginning was for. But, like, it's not enforced, so we changed it.
There you go.
Night before.
Next, we're going to check the frequency of the
It
output.
was something that wasn't supposed to be in our blog.
So we're going to go measure frequency,
Afterwards, it'll just be like,
and we also need to check the duty cycle.
which, I mean, it might have helped if that would have been a bad move, then, like, you would say by adding it early. But
Okay, so we have 3 kilohertz at
we hadn't discussed this, so there's a
10.3%
bunch of
duty
other
cycle.
interfaces that need to be moved around and set up for that.
Thank you.